Welcome to Session 5, where we will talk about ISARS, which are Information Storage and Retrieval Systems. First, we'll define ISARS, and we'll use the Bates article you read for this week to really dig deep into these systems and understand the components of an ISARS. Next, we'll talk about the evaluation of ISARS, and we'll get into metrics like precision and recall, which you read about in the Mahesh paper, and somewhat more so in the Tunkelang blog post. Talking about ISARS fits well at this point in the semester. We started off learning about the information seeking process during week 1, which is the task or process that we as information professionals are interested in understanding and facilitating. Then we learned about users and the foundations of information seeking by learning about the psychology of learning and the philosophy of describing things in the world. Next, we looked more at information and information structures by looking at hierarchies and facets as ways to represent information and information structure. We also talked about relevance as kind of a bridge between the user and the information, with relevance criteria being those characteristics of a resource that a person applies when making a decision as to whether a resource does or does not help the information need. Then last week we talked about metadata, and specifically how metadata elements get arranged into metadata schemas in order to create records or representations of individual resources. So coming out of last week, we understand a good bit about the user side, weeks 1 and 2. We understand a good bit about information, weeks 2, 3, and 4. And now we're going to learn about the technological systems that connect users and information resources. So this is an extremely simplified diagram of an information storage and retrieval system, an ISAR. In this diagram, we see two inputs into the system, the guts of the system itself, then the output of the system. Typically, the user need representation, the first input, that is input into the system is a query, but there can be replacements or enhancements to a simple typed-in query that contribute to the workings of the system. For instance, if you do searches from a lot of apps on your smartphone, you might have the option to filter your results by your current location. If you type Thai food into Yelp, Yelp will ask if it can use your current location. If you say yes, Yelp will communicate with the GPS device in your phone to find out where you are. Then you'll see a list of Thai restaurants sorted with the nearest restaurants first. Even though your location isn't one of the words that you typed into the search box, it's part of the user need representation. So that just goes to show that the user need representation isn't just the query that's submitted by the user. Anything that the system knows about the user that it uses to enhance, customize, filter, or rank results is a user need representation. Now, looking at the other input into the system, at the top right of the diagram, information entities. Last week, we looked at metadata schemas, which are used to create metadata records, which are also known as surrogate records. These records are created for certain types of ISARs, so they're one type of information entity that could be an input to an ISAR. Customarily, libraries, digital libraries, and archives use metadata records as the information entities in their ISARs. Each of these types of organizations, libraries, digital libraries, and archives, has some sort of computer system that allows users to search for resources. A library has an online catalog where you can search for bibliographic records. An archive will have a retrieval system that allows people to search for information about archival collections, often by searching the various metadata fields of archival finding aids. These metadata records are the information entities indicated in the diagram as an input into the system. In Google and other web search engines, the information entities are actually very complex indexes that point to all of the web pages that have been crawled and indexed by Google's crawlers. Now, the information itself is the information system itself is the entire complex of machinery and processes that take inputs and use them to create an output. So the information system is the big box in the middle of the diagram. We'll look more at the components of the information system when we get to the Bates article in a few minutes. So when we look at an ISAR, we can think of it in terms as a combination of things and processes. The things that are involved in the ISAR are the user needs representation, which we talked about on the previous slide. The information entity representation, which can be any kind of medium, text, image, audio, video, whatever. Even in the case where full text is available, the resources being retrieved are not what the information system is working on. For example, while Google indexes the full text of web pages on the open web, Google does not exactly store a copy of every web page on its servers. Instead, Google creates a series of indexes. It has an index of words, and for each word in the index, it points to all of the web pages that contain that word. It has an index of images, and for each image in the index, it points to all of the web pages that contain that image. This is a highly simplified summary of how Google works, but it's a more accurate summary than for you to assume that every full-text ISAR you use is scanning actual copies of actual web pages every time a query is submitted to the ISAR. Now, the third thing in our list of ISAR components is the technical infrastructure. And these are the physical things that make the system work, like the servers, the network connections, that kind of thing. Moving on, we also have processes that are a major part of what happens in ISARs. The major processes at work in an ISAR are storage, and the records stored are some kind of representation of information resources. And sometimes these representations are organized so that retrieval operations can be executed faster and more efficiently. Retrieval is the core process that happens in the information system. When a query is taken from input and compared with information entities in storage, and every time that comparison results in a match, the information entity is retrieved. Ranking is what happens when the system takes all of the results from the matching operation, all of the retrieved results, and puts those results in order, usually according to the goodness of the match between the query and the information resource. Results can be ranked by date or alphabetically, by author, or many other ways. Then the final process is presentation. This is when the system takes the results, which may have been ranked, and displays certain excerpts of the information as entries in a list of results. Again, on Google, the list of results would probably have, as the most prominent portion of each result would be the title of the web page, and then there would be a little blurb of text underneath it, and that would be the presentation of results by listing all of the web pages in such a way. Now that we have a basic understanding of what an ISAR is and how it works, we can start looking at a much more detailed representation of the components or factors of an ISAR system. These are from the article by Marcia Bates that was assigned for this week. And let me say, if you didn't read that article yet, you can get through this lecture, but you really need to go back and read it at some point, because this article in its entirety is a big piece of the puzzle for understanding the big picture of information studies. What Bates does first in the article is she takes apart an information system and shows how the components of the system build upon each other. The components fall into 4 categories, listed as the main bullet points in the slide here. We'll see where these fall in the diagram on the next slide. Now, you might notice that there are fewer components listed in this slide than in Bates's diagram. That's because the components that are listed in this slide are the ones that I'm most concerned in you learning about. The others have less consequence for our discussions in this class, so let's go to the next slide and start talking through the diagram.